There's a bit more in the and your YouTube, like.
All right, so you guys should be down with your quiz. And we're going to start taking a look at our agenda for the day. So I think everybody's back. Welcome. So today we're going to work on, these are some things we're working on. The quiz 8.1, you're going to need your notes for 8A. We're going to finish those up. And we're going to do probably the first half of the notes for 8B. If you want to talk or say anything, you can either unmute yourself or you can hop into the chat room, and we'll leave this chat up so you guys can hop in. And I'll try to keep track of the chat, like the comments in the chat, so I can keep an eye on where you guys are at. Okay, and then we're also going to finish up. Well, okay, so this notes 8A and 8B. We're going to finishing up 8A, and then we're going to start in on 8.3. You have Connect Math 7.3 due today. And then next Tuesday you have Connect Math 8.1, 8.4 due. Next Thursday you have Connect Math 8.3 due. And then April 14th, I'll have you guys finish up and turn in lab problem, lab part 5. I'll have you guys upload that. Please fill out the office hour survey so I can start those next week and know which office hours you guys want or prefer. I think a lot of you guys might like it if I did them like the hour before the homework is due, on Tuesday, Thursday night, so that's totally possible. Also, if you want to pick up handouts at my house, I am in the complex, not on the street. We're going to talk about that a little bit more just in the next few slides, actually. So let me get, Jay, why don't you go ahead and read this one?
With bad internet connections, use phone audio option when you sign in. When you sign in for audio, choose Connect via phone and call one of the phone numbers it shows. Type in the meeting number and pound sign, then type in your user number shown on the screen and pound sign. Then the audio will go through your phone and you can control the mute, unmute on your computer screen.
Right. So it's really important, if you have a bad internet connection, and a lot of you do, I think, because it's a lot, right? My computer doesn't do well with all this much video and audio coming in. Surprisingly, running my audio through my phone helps a lot, like a ton. So I just connect my phone for my audio, and then it leaves so much more bandwidth for the video, and it just makes everything go a lot smoother. So really, really strongly recommend you guys do that. Okay. And then the next thing I want to talk about is where is everything in Canvas. So we have a lot of stuff we brought into Canvas. I've changed things around a little bit to make things a little bit easier for you to find. First of all, I've started announcements. So you go to announcements, that's where all the information that's important is. I'll kind of right here. And then assignments right here, that's where you're going to upload all the stuff for your to kind of your classwork, basically. So your quizzes, a picture of your quizzes, and a picture of whatever page I choose for that day. Today's page is going to be page, you can choose, I'll each choose between 14 or 15, either one, whichever one you think is better, but you'll kind of click on here and you'll be able to upload it there. And then home, if you look at home, the top part is going to be, it's just where we have our links to Zoom and other resources. The next kind of box or group is the handouts you might need, the notes, the quizzes, and also the T-table that you can download. And then the next kind of group is your PowerPoints that I have, and also videos. So those are links to all the videos. I videotape all of your lectures, and I post those up on YouTube, so you can get links to that there. And the kind of fourth group down is the board work PDFs. So again, every time all the times I do this stuff and I write things, I write them on here, and what I write, you can when I write something in here, then you can see what I've written and everything on there. It saves that as that, and that's posted. Those are all in here. So the first group, again, links to our Zoom lectures and some other how-to stuff. Why are our handouts blank? Oh, maybe it should be like that. Okay. Hit this little arrow here to kind of show them all. All of our notes and things like that, PowerPoints and the video. These are all the links to all the videos of these lectures, and then our board of PDFs. And there's other stuff like the project, which you guys are familiar with, and study guides and other things. Okay. Now, what about the handouts? Sonia, can you go ahead and read this?
Yes. Quizzes can be done on plain paper. Don't write the problem, just number each solution. If you are able to write on a PDF via tablet, you can also do that. See number 4 under the March 1st announcement. If you would like to pick up handouts, you can do that either in Pleasanton, the announcement from March is there towards the bottom, or Tracy. Email your address and I can drop them this weekend. Other areas, I can mail them. Email me.
Right. So if you want copies of all the handouts for the rest of the class, I have packets in my front porch. They're there all the time. You can come by any time and just pick them up. Though my house, you have to, it's in the complex, so when you come up my street, you have to turn right into my complex, and then my building will be the first building on the left. So you have to kind of go inside in order to get to them. But you can just walk right up to my porch and grab them. If you are in Tracy or near Tracy, or if you're in Livermore, I'm happy to drop them off this weekend. Just email me your address. I can do that. If you live further out than that, email me, and I can also mail them to you. That's no problem. So I want to make sure everybody has that, because it's really important to be successful to have these handouts. So let's make sure you guys have that. Also, can I drop this class or take it pass, not pass? Yes, absolutely. We have this new thing. We just voted on it. Well, do we have to vote on it? It's definitely available. It's called an extreme withdrawal, just for COVID-19. You can do it anytime until May 19th before the final. Just whenever your final is, you can do it anytime before your final. You just have to fill out a form, and I have a link to that in today's announcement, which again you can find on Canvas. Also, you can take any classes pass, not pass. However, make sure the institution you're transferring to will accept it. CSUs and ECs have put out a statement saying they will accept it for this pass, not passes for this semester, as long as it's not a class in your major. So if you're, say, a history major, you can't take a history class pass, not pass. But you could take this class pass, not pass. That's fine. So you can change this to a pass, not pass. No problem. And again, more information on those is in today's announcements. If you haven't done an assignment yet, do them. That's fine. I'm being really flexible on lateness this time, just because of everything going on. So, if these quizzes and notes that you're supposed to be doing right now, just get them done and get them turned in under assignments under Canvas. If they're more than a week late, I'll probably take off some points, but not all the points, just some of the points. And for Connect Math homeworks, now the late penalty is just going to be 20% for the rest of the semester, because I know people have got things going on and life is happening, so that's no problem. All right, so we're going to start in on Chapter 8. We are on the 8A notes from last class, a hypothesis test. That's a test to see if your sample is unusual or not. That's the whole idea. So it's just a question. That's the whole idea. You're taking a sample, and we're going to see if you expect your sample to be the same as everybody else's. But if your sample is unusual, then we kind of look at it. Because the hypothesis test, the null hypothesis, says that your mean is the same as everybody else's mean. So for example, I had this smart pill. If you take my smart pill, I'm telling you that your scores are going to go up. So I'm saying the null hypothesis says that the mean of people who take my smart pill is the same as everybody else. It doesn't change. It says they're the same. So The null hypothesis says that people taking my smart pill are going to be the same as everyone else. They're going to be right here. That's where their average is going to be. And if my sample, if people I take a sample of people who are taking my drug, and I have them take this test, and if that sample falls in this usual range, this kind of blue range right in here, then I don't dispute the fact that mine is the same as everybody else's. But if I'm lucky, I'm hoping that my people with my drug, the sample has them get an average out here in this unusual range, because then I can prove and say, hey, look, they got something way out here. It can't be by chance. It has to be that my drug really does make you smarter. Who is that who is not muted? Because you are making all sorts of noise. I'm going to randomly start muting people. So make sure you're muted because we should not be hearing you. Okay. That might have done it. Okay. Any rate, so that's the whole concept. You take a sample, and usually you want to be unusual. Usually you want to prove that your sample is different than the general population, right? People with my smart pill, they do better than people who are just regular without my smart pill. So typically you want to find something out here. Not always, but often. So usually you want to reject the null hypothesis. The null hypothesis says that you are the same as everybody else. And typically you would like to reject that and say that, no, 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 I'm different. My people are different. All right, so that's the whole idea behind this hypothesis test. That's your kind of your goal. So let's get a reader. Chris, can you go ahead and read this?
The null hypothesis, symbolized by H0, is a statistical hypothesis that states there is no difference between two parameters. The alternate hypothesis, denoted by H1 or HA, is the statement that the parameter has a value that somehow differs from the null hypothesis. The symbolic form of the alternative hypothesis must match must use one of these symbols, greater than, less than, or equal to.
Right, exactly. So null hypothesis, again, null hypothesis is null difference, no difference. If two things have no difference, that means they're the same, they're equal. So null is always, always, always equal. The null hypothesis is always going to be equal. Something equals something else. The alternative hypothesis is different than the null hypothesis. It differs somehow. So how are you different from equals? You're going to be greater than, less than, or not equal to. You're going to be one of those. Right? Because it has to be different. It has to be, it's alternative. It's different than equals. So for this one, you guys are supposed to find the claim and then figure out what H0 is and what H1 is and whether it is a one-tailed or two-tailed test. So the first one, symbolic form. The claim is that the mean weight that's mu is equals 105. So you should have mu, oops, I'm going to change this to a different color, equals 105. So that's what you guys should have. Now, H0 is always going to be equals. You guys know that, right? We talked about that last time. So H0 is always going to be mu equals or P equals. And this number here, this 105, you guys pay attention. This 105 stays the same. 105 is whatever you have in your claim. That's going to be the same number here, same number there. 105 doesn't change. What changes is this symbol, equals, less than, greater than, not equal to. That's what's going to change from here to here. So my first one, H0 is always equals. So it's going to be, H0 is going to be that mu equals 105. So then your next question is, well, is my claim the same as H0? And it is, because they both say equals. The 105 will always be the same, but the equals, the symbol, equals, equals, those are the same. So then, that means that H1 has to be, since H0 is my claim, H1 has to be the opposite of whatever HO is, H0 is. So this would be the opposite of equals. Mu is not equal to 105. Let's see if I can do this properly without messing it up. Not equal to, like that. So here, again, this is my claim. Since my claim is H naught, then H1 becomes the opposite of my claim. Is this one-tailed or two-tailed test? Oh, where's my chat? Oh, I lost my chat. Chat. You guys chat. Is this one-tailed or two-tailed? Give me, tell me. Yep, two-tailed, exactly. Good. Great. Nice. Someone asked how to upload the quiz during class. Don't upload it now during class. Upload it after class. Like, tonight, later. Don't upload it now. I don't want it now. And how do you upload it? You take a picture of it with your phone, and then you can save that and then you can upload it onto Canvas from your phone. That's probably the easiest, because your phone should all be able to access Canvas. So just go on your phone in Canvas, go to Assignments, take a picture of your papers, and upload them. Okay. Here's quiz 2. Again, we're looking at the claim first. So believes, this is the claim. Believes. He believes what? His oxygen levels. My data is numerical, so it's going to be mu. His mu is going to be higher than, that means greater than 65. So your symbolic form is going to be that your mu, his mu, is going to be greater than, higher than 65. Now, H naught is always going to be equals. So I'm going to take this 65, and I'm going to change the symbol to equals. Because remember, H naught is always equals. So the 65 stays the same. That doesn't change. What changes is this symbol. So it's going to be mu equals 65. Now here's the question. Are these two the same? No, they're not. This is greater than, this is equals. So since they're not the same, then H1 has to be whatever my claim is. I have to make H1 my claim, because my claim has to be one of these two. If my claim isn't equals, then H1 is my claim. So that becomes mu is greater than 65. Okay. So first of all, this is a one-tailed or two-tailed test. Yep. Perfect. Good. Great. Excellent. Thanks. Now, just so you guys are clear, almost always your claim is going to be H1 most of the time, because the only time your claim is H naught is when your claim is or equals. So usually your claim will be H1. Not always, but usually your claim is going to be H1. Now, if you look back at this one back here, you guys mute yourselves because we're getting feedback again. This time, when your claim is equals or is, that's when your claim is H naught. And when your claim is H naught, that's when H1 becomes not equal to. So almost always your claim will be H1, except for when your claim is. When your claim is, then H naught becomes your claim, H1 becomes not equal to, the opposite of that. But unless it is, then H1 will always end up being your claim, unless your claim is equals or is. Okay, everybody good with that part? Hopefully? All right. Let's go ahead and move on. The other thing we talked about, do anybody have any questions about that before we move on? If you do, pop them into the...
So what is claim? So what is the claim for question 2?
It's right here. This is the claim. Mu is greater than 65.
Okay, mu greater than 65.
Yeah, you guys might have written like this, mu, right, is greater than 65. You probably would have written something like that, that's my guess. Okay.
Yeah, I had written in the chat box.
Okay. Yeah, I can't read the chat. I can't read that much information in the chat box. All right, I'm going to mute you guys again because, again, we're going to get feedback otherwise. So unmute if you want to talk, and then mute yourselves afterwards. All right, so here, the test stat. So the test stat is the other thing that we went through last class. And remember, the test stat is your sample's z-score. So it's the z-score for your sample. How do you find it? So this is the one this is the one we're sort of familiar with from chapter 6. Right, this is exactly what we did with central limit theorem to find the z-score. X bar minus mu over the new standard deviation, right? The standard deviation for a sample mean, sigma x bar, sigma over square root of n. So that's kind of, that's how you find a z-score. Because remember, if you're talking about a sample, take a sample and talk about the mean of a sample, then your standard deviation is no longer regular sigma. It's now sigma over square root of n. It's become smaller, right? Because you get these things canceling out. So the ones we're not going to actually work with this one though, because it's very unrealistic for us to not know our mu and know our sigma. Instead, we're going to mostly work with this one. If it's a mean, so it's going to be x bar minus mu over s over square root of n. So very, very similar. Or if it's proportion, then we will use this one. This is how you find the z-score. It's p hat, what you get from your sample proportion, minus your p, what you expect to get. So the p or the mu, these are the things that are in your claim. Why are we getting feedback? We're getting feedback still. You guys don't unmute yourselves. All right. Sorry. So the p and the mu, those are the things that are in your claim. That's how you know. That's how you find them. You go over here and say, what was the number in my claim? That is your p or your mu. In this case, it's this is my mu naught. So that's where these guys come from. Okay. And then the standard deviation for a proportion would be square root of PQ over N. All right, let's go back to this one. So just to remind you guys, we did one last class where we talked about X-sort method. They sampled 100 couples, and out of that 100 couples, 58 of them were girls. So 58 out of 100 were girls in their sample. So if you kind of look at it, you expect to get 50% girls, right? So our null hypothesis says that X-sort is the same as everybody else. The proportion of girls they give is 50%, like the rest of the world. But they say, wait, we're better. We'll give you more than 50%. So their claim is that their proportion is going to be higher than 50%. So what we do is we're going to take our sample, 58 out of 100. It should have been 100, I don't know. It should be 100. 58 out of 100, and we're going to find the z-score. So 58%, 0.58 minus 0.55 divided by the standard deviation. So it's right here, right, 0.58, what we got in our sample, our p-hat, minus what we expected to get, 0.5, this is what the population is, divided by the square root of PQ over N. And remember, this PQ, we expect this to be correct, the 0.5. So that's why we're using 0.5 here and here. So 0.5 times 0.5 over N, 100. If you do that, you get 1.6. So that ends up being your test stat, your sample's z-score, how far it is, your sample is from what you expected to get. Okay, so you guys had your quiz. So if you kind of look through this, you have to figure out, well, you got to figure out what your claim is. The easiest thing to figure out is to find your claim first. So my claim is that the proportion P is 25%, 0.25. So this would be your claim. Claim P is equal to 0.25. Okay, and then we have to kind of look at it and figure out what we got going on. So this is when you find your claim, it helps you figure out what your mu is. This is your mu naught. Your sample, you got to take it from the sample. So my sample had 540 P's and 128 of them were yellow. So that means that my sample, p hat, had 128 out of 540 that were yellow. And this is 0.237, is that right? Is that what you guys got? 237, I think. Good? Okay, I'm getting some nods.
237.
Perfect. Great. So then we can, let's see if I can get my board to work. Wouldn't that be a miracle? So then we're going to go ahead and use our formula to figure out what this is. So then our test stat. Oops. Okay, it's a little bit off. Come on. Nope. Okay, it's just not going to go. That's all right.
Did we round it to 2.24?
Yeah, that'd be okay. So, yeah, I don't think it likes the recorder being on at the same time. Yep, that's just not going to work. That's unfortunate. Okay, no worries. Let's try this. Test stat equals, and the top part is going to be 0.237 minus 0.25, and that's going to be over square root of p, 0.25, times q, which is, if p is 0.25, then q must be 0.75, because I have to add up to 100%, over 100. Okay, so let's see if I can make this kind of work reasonably. Like that. Good. So when you get that, what did you guys end up getting? Anybody? Somebody type it in to the chat. So this should be what you guys got. Right. Your p hat minus what you expect to get, this number here, mu naught, divided by square root of, sorry, the p naught, p q over 100. No one? Anyone? Bueller? What did you guys get? If you didn't do it now. I'm just going to wait here forever until people do this, and we could end up going overtime.
If you get the 100, you get that.
No, you get the one.
Oh, sorry, is it 540? I'm so sorry, because I'm totally wrong. Thank you. Because I was working off the last one, I think, apparently. $540. Great. All right, so then, now that I've done it correctly, what did you guys get? So sorry. Anyone? 0.6. Anyone? Really? Yeah, 698. Okay, great. 698. So the easiest way to do this is to find your bottom first. So 0.25 times 0.75. Let's see if I can do that. I don't know if I can do that. I'll try it with WebEmu. I don't know if it'll even come up.
Should it be negative?
It should be negative. Why is this not? I hate this. This is annoying. Okay. Yes, it should be. And I don't think my web email is listed here, is it? Oh, of course not. Okay. Yes, I'm sorry. Negative. Thank you, Angel. So right, because it's less than, so it should be negative 0.698, or you can just make it negative 0.70. That'd be all right too. So the easiest way to do it is to do this part first inside, 0.25 times 0.75 divided by 540, and then raise that, after you find that, raise it to the 1/2 power. So you would do raise it to the 0.5 power, that's taking the square root of it. Find that separately, write it down, and then do this minus that divided by whatever that number you get is. And that's the easiest way to do it, is to find your bottom first, write it down, and then do the top, find the top, and then divide it by the bottom, whatever you found for the bottom. Okay. Stop. Okay. So sorry. All right. We did this. We did not do this part here. Okay. Maybe I should do it better. Remember we talked about this one. If you're rejecting H naught, if H naught is your claim, then rejecting H naught rejects your claim. Whereas if H1 is your claim, then rejecting H naught supports your claim. And that's where this whole QRS kind of helps in to help you remember these two. But H naught goes with reject, and H1 goes with S because R comes before S. So here's kind of what I meant to do with you guys. My claim here was H naught. So if I reject H naught, what happens to my claim? If I reject H naught, then I reject my claim. Does that sort of make sense for people? If I'm rejecting this, then I reject my claim. Whereas if I look at a situation where my claim is H1, here it's like he says that he's going to increase the life. You guys mute. I'm going to mute you guys. Oh, mute this one. There. I'll try that. H1 is my claim. Then what happens if I reject H naught? If H1 is my claim, if I reject H naught, what does that do for my claim? Does it help it or hurt it? If I reject H naught and H1 is my claim, that helps my claim, that supports my claim. So that is sort of what we're getting at here. Why is there always all this feedback? Sorry, I'm trying to see what's going on here.
Professor Young, there's a couple students that are asking for help in the chat.
Okay, good. Which did you want help with? Oh, it helps it. I think she's saying it helps it. It helps the claim, I think. That's my guess. Yeah, exactly. Nice. It helps the claim. Perfect. Well done. Thank you, Jackie. All right. So that's kind of what I wanted to talk about there. We did not talk about hypothesis testing errors, though. So now let's talk about the errors. There's two situations that can come up if you reject H naught. So first of all, if I reject H naught, then ideally we do that whenever H naught is false. So for example, the proportion of red cards. If I say my proportion of red cards in my deck is 50%, that's my H naught, right? My cards have 50% red cards. If I reject H naught because I got something unusual, that's usually the correct answer, because if you guys remember back when I had my deck of cards and you guys are drawing it to try to figure out if you can win a truffle, my proportion of red cards was not 50%. It was much higher than 50%. So you would reject the null hypothesis and say, no, my proportion was not 50%, it's something higher. So you're going to reject H naught correctly. So that's typically what will hopefully happen. Occasionally, you might reject H naught, and it would be a mistake. You'd say, oh, wait, really, my red cards really were 50% red, but you guys just happened to randomly pick 6 red cards in a row. It can happen. Doesn't happen very often, but it could happen. So that would be an error to say that, to reject H naught and say that my proportion was different, if my proportion really was 50%. So assuming my cards really were 50% red cards, and we got something unusual, we got those 6 red cards in a row and rejected H naught, if my deck really did have 50% red cards, then that would have been an error. If my deck actually had more red cards, like say 100% red cards, then that would have been a correct decision, right? Because I did have higher than 50%. You just don't know. And sometimes, you know, if your alpha is 5%, then that means 5% of the time you're going to randomly get something unusual, right? It could happen. You could totally draw 6 red cards in a row. I don't know if I told you guys about the time that I bet on Banker in Vegas, that Baccarat table. I think I told you guys. And I bet $25 on Banker, the roughly 50-50, it came player. So I bet another $25 on Banker. It came player. So I bet $50 on Banker. It came player. I bet $100 on Banker. It came player. I bet $200 on Banker. It came player. And I bet what I had left, I think $375 on Banker, and it came player. So it's super unlikely it comes player 1, 2, 3, 4, 5, 6 times in a row, but it totally could happen. And I lost like $800 almost on that, because it's possible, right? So it's unlikely, but it's totally possible that it could happen. So, you know, maybe my deck really did have 50% red cards, and you guys just happened to draw 6 red cards in a row, which is unusual and unlikely, and we guessed that H naught was incorrect, that my proportion wasn't 50%, but maybe it really was, and you guys just happened to randomly pick, you know, 6 red cards in a row. So it could happen. It could just be a random error, a random unlikely event. But more likely, my deck was fixed, and I had a lot of red cards in there. The other error that could happen is that you don't reject H naught, and H naught really is true. So that could happen, and that's actually a good thing, right? So my deck is 50% red cards. You guys drew, you know, 4 out of 6 red cards and said, oh, it seems okay, reasonable, and you don't reject H naught. Now, it would be an error if my deck really is different and you guys don't have enough evidence to reject it. So typically that happens in cases like, let's go back to the one up here, this guy here, this X sort. So the X sort, we're saying that here's my little thing here, and I got something that was kind of unusual, but not super unusual. So what we got was 1.6. So we got something kind of here. And it wasn't quite enough to say it was unusual. This is like, say, you know, maybe it was 1.60, which seems kind of unusual, but we know that usually it's right around 2 where it really becomes unusual. But it might be that X sort really does make you have more girls than boys. So it might be that it does actually increase the likelihood. We just couldn't prove it because it wasn't extreme enough. 1.6 was pretty good evidence, but not enough evidence. So that's the other flip of the coin, is that the more evidence you require someone to have, in other words, the higher your alpha, the more likely it is that, the smaller your alpha, the more likely it is that you won't accidentally reject the null hypothesis, but that means the more likely that you will accidentally not say something's different when it really is different. Right, so here's an example of the type 1 error again. So we take a bunch of samples, take them all around here, and most of the samples that we take are going to be right around the mean. But, you don't know what sample, you've only taken one of these samples. These each represent a sample of 30, and you don't know that your sample that you took happens to be unusual. It's way out here. And, because it's so far away, you say, oh, it's not the same as the mean, and I'm going to reject the null hypothesis. So that happens, a reasonable amount of time, 5% of the time, to type 1 error. Because 5% of the time, you're going to randomly get something unusual, right? I mean, we kind of set this situation up to say that 95% of the time, the stuff that's 95% likely to happen, that's going to be usual, and stuff that's 5% likely to happen is unusual, which means that 5% of the time, you're going to get something unusual. You guys remember how we did that video about how 64% of published papers are false? It's because, out of 1 million tests that experiments people run, 5% of them are randomly going to get an unusual event. And thus, that 5%, they don't know that they're unusual, and they write a paper. And then people can't reproduce it. So this level that we set for unusualness, typically a level of unusualness in statistics usually is what? Typically 5%, right? We set that arbitrarily, usually it's 5%, which means that 5% of the time, we're going to get something, 5% of the time we're going to get an unusual result, just randomly. So 5% of the time we're going to get this type 1 error, where we don't know that we've got an unusual sample. And likewise, the type 2 error is beta. That's when you don't reject something that you should. So hypothesis testing, typically our alphas are 5%. Sometimes it's 10%, sometimes it's 1%, but these are the kind of typical significance levels that we see very often. So, for example, if your alpha's 0.10, that means there's a 10% chance of rejecting a true null hypothesis because there's a 10% chance you've just randomly gotten an unusual sample without realizing it. Just so you know, that's the same alpha we had in chapter 7. Hasn't changed. It's the same. Alpha's the same. So why don't you guys take a minute and go back into your Zoom groups and talk about